Hello and welcome back to my Physics 1 topical video short lectures. Today's video is another of these videos that we are doing as preliminary and prerequisite knowledge for our Physics 1 course. In this particular video, I'm going to be introducing significant figures. I'm going to have a follow-up video to discuss how to handle significant figures when doing calculations with numbers. Today's video is just to introduce the concept of significant figures, basically to talk about what is and is not a significant figure, to tell you what significant figures do, and maybe do a couple examples to show you via example. So that will be in today's video, and then we'll have another one to talk about rules for addition and subtraction, multiplication and division. So let's get into it for today's video. So let's start off with just what they are and what they do. So the simplest definition for what a significant figure is it's any digits which are not zero, or trailing zeros after a decimal, or captive zeros. And in some sense, it's actually easier to define what is not a significant figure than what is a significant figure. So only zeros used to locate the decimal, or in other words, the ones place versus the tenths place, only those are not significant. Now, you may wonder why I didn't just say any zeros after a train of non-zero numbers, assuming that you don't have a decimal point and then some other numbers afterwards. And the answer is because although mathematically we would say those are not significant, although the usual rule would say those are not significant figures, they actually can be significant. They're kind of ambiguous. And I'll write some examples in a minute. What is it that they do, though? Why do we care about significant figures? Well, they're basically one method for sort of showing what precision a number is stated or known to. So they, in some sense, they denote the precision, oops, I'm going to misspell that word. They denote the precision of a number. All right. So let's say that you decide to take the measurement of the wall in a room. So I have this nice wall behind me, and maybe you have several ways of trying to measure it, right? So you have a ruler, you have a meter stick, and you have a tape measure. And using the tape measure, maybe you measure it, maybe you have some other friends that are going to double check your measurements. You know, you may have heard this saying, measure twice, then cut once. So you take your tape measure and you measure the wall, and maybe you decide that you're going to do it in inches, for example. And so you say, okay, well, this wall happens to be, according to my tape measure, 144 inches from one corner to the other. And then your friends all measure it, and everybody comes up with that same 144 inches number. All right. So you'd be able to then say, all right, well, we know that the measurement of this room's length is 144 inches. So let's write that down here, 144 inches. Oops, that doesn't look very well written. Apologies for the bad handwriting. Okay, so 144 inches, great. Can you say that it's exactly 144 inches? Is it possible that it's actually 144 1/8 inches? Would you have noticed the difference with this measurement? Maybe you would have, maybe you wouldn't have. So if you can measure to the nearest inch, let's say, and maybe even measure and estimate to the nearest inch, but you can't get the next digit after that, in other words, you can't distinguish between 144.0, 144.1, 143.9, any of those, then you would say that you can specify out to this many digits, and you'd say, okay, we have 3 digits of precision. And this also means that we have, or should have, 3 significant figures. And by the way, we will sometimes abbreviate significant figures as sig fig, and some will even just abbreviate it as S.F. All right, so that was using a tape measure. Now let's say that you forgot to write that down, and so you come back the next day and you need to remeasure it. And on the next day when you need to remeasure it, all you have available is a ruler. So now you go across the room with the ruler, and when you're measuring across the room, what do? You kind of like take the ruler, put it on the wall, and then you like stick your finger at the end, move to where your finger is, start over, etc. You can imagine that this is probably not going to be as good of a measurement as using the tape measure. Your finger could slip a little bit. The ruler has a start and an end line, and your finger is maybe a bit thicker than those lines. Even if you try to draw like a little line with a pencil or something on the wall, you end up with a little bit of slippage. So maybe now you go and you measure it, and you have measured 142 inches, but your friend measures 145 inches, and your next friend measures 143 inches. The next one measures 141 inches. Maybe some others get like 147 inches. You know, somebody's just really sloppy. Okay. So what level of precision do you know this room to at this point? Well, this gets into a deeper conversation, which has to do with statistics. But by and large, everybody here would be able to agree that the room is around, let's say, 140 inches and is somewhat less than 150 inches. So you might now write 140 to 150 inches. You now have only 2 digits of precision. And you may say as an estimate, so estimate 145 inches. You again would have 3 significant figures, so 3 sig figs. Or you may just say, you know, we have to round up to 150 inches, and then when we buy the wallpaper or whatever you're putting in the room, we will have to cut accordingly. Okay? So that's basically what significant figures are doing for us. Now let's write a few numbers, and we will see like what in the number counts as significant figures and what doesn't. Okay, so one number, you might have the number 10. You might have the number 10.1. You might have the number 0.0325. You might have the number 1002.04. You might have the number, oh, let's say 100 even. Let's make it 300 even, just for variety. Okay. And so how many significant figures does each of these have? Let's do one more. Let's say that you have 0.004610. Okay. So how many significant figures does each of these have? Well, this one right here has either 1 or 2 sig figs. So we're starting off with some ambiguity right off the bat. It's either 1 or 2. This one is definitely significant. So this is a yes. This one is a maybe. And we would know whether it's significant or not because you'd have some context clues. You'd need context clues in order to know. If you've got a list of numbers and it's like 9, 10, 11, 12, 9 again, 8, 12, 10, 13, then that 0 is probably significant. If your list includes numbers that look like 10, 20, 10, 0, then that 0 is probably not significant. So it's context-based. Okay, next number down, this one actually is known to have 3 significant figures. Why? Well, because this and this, the two ones, they're always significant. This 0 that's between two other significant digits is what's called a captive 0. So it is significant because it's between two other significant figures. This number right here also has 3 significant figures. Basically, these are all non-zero, so 3 non-zeros. There's no captive zeros. And these other two, the 0.0, these are not significant. So not significant because they just locate the decimal. In other words, we could rewrite this number in scientific notation, if you watched the previous video, as 3.25 times 10 to the minus 2. We wouldn't need to include these two zeros. This number, we would need to include the 0. This number in scientific notation would be 1.01 times 10 to the 1. This number right here would be 3.25 times 10 to the minus 2. We needed to write this 0. We didn't need to write these zeros. All right. This number right here has all these digits are significant. So this one actually has 6 significant figures. Okay, anything that it's not a 0 is significant. And these two are captive. So these are captive zeros. And this is also a captive 0. So captive zeros, if you come up here, captive zeros count as significant. So this one, all the digits are significant. This one's ambiguous. 1 or 2 or 3. We don't know. We know that this is definitely significant. Either of these, this one might be, and if this one is, then this one also might be. This one can't be if this one isn't, however. But you could have, this number could be 300 as distinct from 290, 280, 310, etc. But not as distinct from 301 or 299, in which case you have 2 significant figures. Could be 300 as distinct from 299 and 301, in which case all three are significant. Or it could be 300 as distinct only from 100 and 200, in which case there's only one significant figure. You'd need to write it in scientific notation to know how many for sure. All right, this one right here, we actually have 4 significant figures. This one right here is a trailing 0 after decimal. And so there are 4 sig figs. Okay, one more just for variety. I have this number up here, 10. If I write 10.0 rather than 10, this one right here actually has 3 sig figs. This is a trailing 0. This one, since this is significant and this is significant, this one becomes a captive 0. Okay. So that is basically significant figures for you. We don't have time in this video to go over the rules of addition, but we will in a future video. I do, however, want to give a couple examples, kind of like a your turn to play quiz first. Okay, our first example is to write the number pi, but to 2 significant figures. So you know that pi is, approximately 3.14159, etc., etc., etc. You can go out to as many digits as you want. But we want with 2 significant figures. So that means that we're really looking at these 2 digits and then this one to tell us whether we should round up or down. Now if this digit is 5 or higher, we should round up. If it's 4 or lower, we should round down. Since this is a 4, we're rounding down. So we can say that to 2 significant figures, pi is approximately 3.1. Second example, you have the number 300,000 and we want to write it with 3 significant figures. We can use scientific notation to do this. So you know that in scientific notation, I'm moving the decimal from here 1, 2, 3, 4, 5. So I know that this is going to be 3 point maybe something times 10 to the 5. I want 3 significant figures, so I need to add 2 figures after the decimal point. Those 2 are both zeros since this is 300,000. So this would be this number with 3 significant figures. All right. And I think that will suffice for today's short video. So thanks for watching, and see you in the next one.